All right, let's go ahead and go over the answers. So for problem number 1, it says, on a game show, a contestant correctly answered 9 out of 12 questions. If the show asks him 64 questions, how many would you expect for him to get wrong? What do you think? Let's go with Alexander. 16. Very good. 16 would be considered to get wrong. The information that they're giving to you is how much correct he answered. 9 out of 12 questions. Which means if you want to know how much he did wrong, you have to take 9 away from 12. He did 3 out of 12 wrong, right? 3 out of 12 is considered to be the incorrect portion. 3 out of 12 is the incorrect portion. Now you can use that to be able to set up a proportion. 3 out of 12, so it's 3 wrong out of 12 total. You're going to set it up to a proportion. You want to know how many wrong out of now 64 total. Okay, that's your new proportion that you would set up. You then do your cross product. We're going to multiply 12 times the x, which gives you 12x. You're going to multiply 3 times 64, and that's going to give you 192. And then you're going to go ahead and divide both sides by 12. So that would give you x equaling 16 wrong. That's your expectation, that he will answer 16 questions wrong. It's a prediction, doesn't mean it's exactly how it's going to work. It's just making an estimation based off of information that you have been given. Okay, number 2, Northbrook Middle School is considering having a football team. In order to get an unbiased sample, who should they survey in the school? So the first thing you want to focus on is your method. Who can raise their hand and tell me one of the unbiased sample methods? Abby? A random sample. A random sample is considered to be an unbiased method. So you might want to do a random selection. Or there's a second sampling method. What is that going to be, Philip?
Systematic random.
Systematic random. Systematic meaning that you would choose like every 20th person. Okay, so in a response like this, you should have either a word of, I'll do a random sample of, or I will do a systematic sample by taking every 15th person that walks into such and such area. Now, again, to be unbiased, it's not just about the method. It's also about a location. You need a location that's going to give you a variety of people. So if I want to find out what Northbrook Middle School students think about having a football team, I want to know a place where all grade levels are going to convene at some point in the day. What is one place in this school, guys, that everybody at some point has to go through? Lunch. The cafeteria. So you are probably going to do a random sample or a systematic sample in the cafeteria. For places like school, the cafeteria is the best place to perform a survey. If you are performing a survey in your community, a grocery store is a great place. A mall is a great place. You want to go to some place where you're going to have all sorts of ages, all sorts of social economic backgrounds, all sorts of genders, Grocery store is great because at some point you gotta go grocery shopping, right? Everybody's gotta get food. Okay? The mall's a great place to do the surveys because you've got all sorts of different people there. Now, I wouldn't want to go to a specific store in the mall because does everybody go to the same store? No. Okay? Some people might go to H&M. Other people maybe they go to Journey. Who knows? So, some people might be stuck in the, food court all the time. Or if you're me, I'm always stuck at the carousel when I'm there. That's all my kids want to do. All right? So it's just about making sure you get a location where everybody's going to pass through. All right. Number 3. Problem number 3. Lisa asked 80 students in the orchestra if they like classical music. 59 students said yes. So she concludes that 705 of the 956 students at the school will like classical music. Is this conclusion valid or invalid? And explain. We want to know, is it valid or invalid? And an explanation to go along with it. So we're going to go with Allison. What did you say?
I think it's invalid because the reason why she got 705 is she didn't round it.
Well, she did round.
Well, she didn't round it correctly. She was supposed to round it to the next one.
Not necessarily. It's rounded correctly. The numbers are correct. It's still invalid. Because here, guys, with a situation like this, when you're talking about validity, are we focusing on numbers at all? No. You're focusing on who she surveyed. Did she survey a valid group that's unbiased? No. Why not, Philip?
She asked the orchestra kids.
She asked the orchestra kids. Now, if I'm in orchestra, chances are I either chose to be there, so I might like classical music, or I'm forced to be there, but after so many years of having to perform, I started to kind of get a liking of classical music. So it creates a bias. It's creating a bias. The math itself is correct. Okay, the math itself is correct. But the math, the numbers mean nothing. So I want you to write that down in big bold letters. When checking for validity, is this a valid survey? Or is this information valid? Conclusions. Numbers mean nothing. When you're identifying if something is valid, the numbers mean nothing. Has absolutely nothing to do with the numbers whatsoever. It has everything to do with who she asked. So in this case, this is invalid. It is invalid because of who she asked. She focused on one particular group. She only focused on students that are in orchestra. So validity means a bias. Bias and validity, those are the similar kind of concepts, okay? Are there any questions in regards to this warm-up? Okay, so what you're going to be doing today is I'm going to hand out to you a worksheet. I don't like doing worksheets very often. But this worksheet is an independent practice. It's going to go over predictions, making predictions. Please make sure that you round you must make sure you round, especially when you're talking about people. With survey information, you need to round because it's talking about people. So make sure you're rounding correctly. And the second page is talking about biased and unbiased. So you're going to identify the sample method. Was it random, systematic, convenience, or voluntary? And then you're going to indicate, is that biased or unbiased? Okay, it's a front and a back on that one. So make sure that you're doing the whole thing. You've got the entire class period to do this. We're going to go over it in class first thing tomorrow when you come into class tomorrow, okay?